Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss transistor biasing and stabilization circuits. Let's begin. Transistor biasing is the proper flow of zero signal collector current and the maintenance of proper collector emitter voltage during the passage of signal. In the previous video lecture, when we are dealing with DC load line, we consider a common emitter NPN transistor, and it has no signal as input. The transistor is said to be proper biased. What it means that transistor is fully functional and the transistor is said to be proper biased when that emitter base junction is to be forward biased. When it is forward biased, here NPN, so P type is connected to positive terminal and N type is connected to negative terminal, then it is said to be forward biased. And emitter collector junction must be reverse biased. Reverse biased in the sense that terminal is connected to positive, this one is connected to negative. Here collector and emitter junction is reverse biased. Their base emitter junction is forward biased for NPN transistor. It is forward biased. That one is reverse biased, and we say that NPN transistor having common emitter mode is properly functioning, which is said to be proper biased transistor. So transistor biasing is the proper flow of zero signal collector current. The current flow, here is the collector current, that is the maintenance of proper collector emitter voltage. That voltage is the collector emitter voltage during that passage of signal. That is known as transistor biasing. Next, for faithful amplification, basically transistors are used for amplification purpose. For faithful amplification, it is necessary that the operating point is fixed. Look here, what is the operating point? That has already been discussed in previous video. If we plot the graph in between collector emitter voltage collector emitter voltage and collector current taking as base current as constant for a particular base current. Let that base current as 10 microampere, and we plot the DC load line. This is the DC load line AB as a DC load line, and that DC load line intersects to the curve IB at a point. That point is known as Q point, that is Q point, or we call it as operating point. That Q point is fixed for a proper biased transistor. If that Q point is fixed, then by analyzing that Q point, we can find out what is the collector current at particular collector emitter voltage. If any variation occurred to that of Q point, then the action of transistor is not holds good. In the sense, we called the biasing is totally affected. Hence, the operating point must be independent of variation in temperature and transistor parameter, and this is known as stabilization. Why that line indicate, why that line we write as operating point must be independent of variation in temperature and transistor parameter. If any variation occurred in that of operating point, or that operating point fluctuates, means the transistor not worked properly, and that fluctuation in Q point occurred when temperature vary or transistor parameter varies. We can analyze that point. If Q point is fixed, then it is called stabilization, and that Q point is affected by two or three factors, that is variation in temperature, transistor parameters, or thermal runaway. The stabilization affected or we can say the variation in Q point by the factors as factor number 1, temperature variation. Let me understand it. What is temperature variation? For that reason, we write it must be independent of variation in temperature. We know collector current I of C is equal to beta I of B, amplification factor beta, base current, plus 1 plus beta whole into ICBO, that is the leakage current. From that of expression, it is clear that ICBO leakage current is affected by temperature. ICBO, that is the leakage current, is affected by temperature variation. If we take the transistor is made up of in germanium, then that leakage current is doubled with the increase of temperature as 10 degrees Celsius. As you know that Q point is basically denotes the relation of collector current to that of common emitter voltage. If that leakage current vary with temperature, then IC affected, then IC also vary. As a result, Q point is not fixed. So, temperature variation is the cause that affect the variation in Q point. Okay. Next, another aspect which is responsible for variation in that of operating point or Q point, that one is variation in transistor parameter. What is variation in transistor parameter? If we buy two transistors of a same company, but in that two transistors the amplification factor beta is different. If we replace one transistor with another transistor, then its amplification factor differs. As that amplification factor differs, therefore IB is affected, as IB is relative with IC. At that point, Q point also not fixed. So, we write it, when we buy two transistors with amplification factor beta of the same company, beta from the same company, but it is differ in beta. Therefore, when we replace it, then that beta also affected, changes. As a result, IB, that is the base current, also changes. Then it relates with IC as changing. In this way Q point as a result that Q point is not fixed. That is another cause. Variation in transistor parameter influence the change in the position of that Q point. Next point is the thermal runway. Thermal runway. Same equation as I of CBU, that is the liquid current, that is related with that of temperature variation. As temperature increases, also heat generates. As a result, heat is generated in a huge amount, so IC and IB also affects. Here ICBO, which is leakage current, is affected by temperature. Then it relates with IC and IB by taking a change in temperature. So Q point also affected. These three are the important aspects on which Q point fluctuates. One is temperature variation, another one is variation in transistor parameter, last one is thermal runway. For that reason, we write that point, the operating point must be independent of variation in temperature and transistor parameter. Then we say that is stabilized. If that operating point or Q point is fixed, then that transistor is said to be proper biased, and we obtain the collector current with the proper maintenance of collector emitter voltage. Another technical term, by using that technical term, we can say either that transistor is stabilized or not, that is the stability factor. We define stability factor, it is defined as the rate of change of collector current with respect to the collector base leakage current, at constant amplification factor beta and base current IB. So, the stability factor S is equal to the rate of change of collector current d of IC. How collector current change? with respect to the collector base leakage current d of ICBO at constant what amplification factor and base current. Mathematically we define stability factor. If stability factor is more, then we can say that transistor is stable. If it is less, then that transistor is not stable. Sorry, if it is less, then we call the transistor is stable. If it is more, then it is not stable. On that basis, the stability factor define either the transistor is stable or not. In this way, with the help of this video lecture, we understand the concept of transistor biasing and stabilization circuit. So, what is the transistor biasing, stabilization, what are the points that affects stabilization, temperature variation, variation in transistor parameter and thermal runaway, and finally discussing about stability factor. On that stability factor, we say either that the transistor is stable or not. So, with this useful and informative notes, let me wind up this session. Thank you.